Alright, today we are going to be talking about parallelograms. Okay, so a parallelogram, you can get this for the vocab definition. It's going to be a quadrilateral that has parallel opposite sides. Alright, now there are a couple of theorems and things about parallelograms when you have them. So if a quadrilateral is a parallelogram, then the opposite sides are going to be congruent. So we can go and say that the side RS is congruent to the side QP, and then QR is congruent to PS. Okay, so opposite sides are congruent. Okay, another thing, if a quadrilateral is a parallelogram, then the opposite angles are going to be congruent, and these are the angles across from one another there. So if you have angle P, that should be congruent to angle R. And then if you have angle S, that should be congruent to angle Q. Pretty straightforward there. If a quadrilateral is a parallelogram, then the consecutive angles are, and think back to way back in when we were talking in Unit 3 about consecutive interior angles. These two angles, like for example X and Y right there, those are going to be supplementary. Alright, we learned that way back when we're talking about consecutive interior angles when they touch parallel lines. So we can say X plus Y is equal to 180. There's also other combinations. You can say, well, I guess they're all the same, but X plus Y right there is equal to 180. X plus Y right there is equal to 180. Every combination, every side-by-side angle is going to be supplementary. All right, and then if a quadrilateral is a parallelogram, then the diagonals blank each other. We're going to say they bisect each other. So that means this little piece of the full diagonal is congruent to that little piece of the full diagonal. So QM is congruent to MS. And then also go in the other direction. This part of your diagonal PM is congruent to MR. So those little pieces are congruent to one another. Right there. So we'll fill that out here where we got QM, MS, PM, and MR. And there you go. Alright, and then also we're going to, in this unit, prove that prove that quadrilaterals are going to be parallelograms specifically. So if you have certain combinations of things, then you can go ahead and say that. So we can say if one pair of opposite sides of a quadrilateral is both congruent, I'll just use the symbols there, and parallel at the same times, then the quadrilateral is a parallelogram. And by the way, I kind of forgot to mention this. You can prove all this stuff here by drawing maybe a segment in between, and then you're going to prove like triangles being congruent and all that fun jazz there by like side angle side, that type of stuff right there. So that's how you prove that all of these theorems. Alright, so let's see what's going on here. I guess in this case here, find the indicated measure in the parallelogram. The symbol right here kind of looks like a parallelogram. That means parallelogram. So KLMN, and then shown at the right. So check this out here. We got a parallelogram. All sides are parallel to each other. So you can look at the markings. You can look at what's given to us at the very beginning. Check this out here. You have 37 equals 2x and then minus 3. And then you want to add 3 to both sides. And then you want to divide by 2, x equals 20. Okay, so that'll give us our x value. Y. So angle Y should be congruent to the angle opposite of it. So Y should just be 123. And they already have a degrees on the Y, so you can put degrees if you want. You don't necessarily need to there. Z, we can find that because we know consecutive interior angles are going to be supplementary. So we'll say 180 minus 123, and what was that, 57, I think? That'd be your answer there. That's how you use all the stuff from a quadrilateral there. For what value of x is the quadrilateral a parallelogram? So we know that the diagonals of a parallelogram bisect each other. So if these two were congruent, so if I can find a common x value between them, then we can say that these two pieces should be congruent. So all you do is just set them equal to each other, which is really not that bad. 2x plus 9, subtract over, you're going to get 3x equals 9, therefore x equals 3. It's pretty straightforward there on that one, not anything too wild. Okay, show that this quadrilateral, a little Cartesian plane, is a parallelogram. Couple different ways you can do this. My personal favorite way, because it's the easiest, is showing that the sides are parallel. So that's what we're going to do here. There's different ways you can do it. But to show that the sides are parallel when they give you a graph like this, we want to go and think about what does it mean to have parallel lines in a graph. And what we think about there is parallel slopes. Don't forget, parallel slopes are the same. So if we can prove that the slopes are the same, then we are good to go. Okay, so we'll go ahead and do that on this one here. So if you go and count your slope here, slope, remember that's always rise over run. So I'm looking here, it looks like it's going down 2 and then over 1 for the slope of LM. And then the slope of KM is going down 2 and over 1. So we can say something about this is how I usually write it, like M, and then of, what do we got? LM, I guess. So the slope of LM is equal to negative 1/2 down 1 over, or down, I'm sorry, down 2 over 1. So negative 2. And then the N of Kn was also negative 2. And then you can also, so that shows two sides are parallel. You need all opposite sides being parallel. So we can go find the slopes of those two lines right there. So you got KL now. And that looks like it's going up 1 over 1. So that would be a slope of 1. All right, and then what is this? NM. Whoops. NM, kind of like that right there. And then just 1 right there. The slope up 1 over 1, up 1 over 1, so you're good to go there. Now, another way you can do this here is proving a couple of other things here. You can use different combinations. Like we talked about this converse right here, saying if you have a pair of sides that are congruent and parallel at the same time, then it's a parallelogram. You can talk about maybe the diagonals bisecting each other. I probably wouldn't do that one. That's probably going to take a little bit longer. Or you could show that all pairs of sides are congruent, or actually I should say all pairs of opposite sides are congruent. So like for example, if you wanted to prove that LM is congruent to KM, you'd have to do a little bit of distance formula, or you would need to do some Pythagorean theorem. So like you could go and take these ordered pairs, and we'll have to do this in a later section. So this is good here. So I'm going to say LM, I'm going to do the distance formula with that. And then I'm going to say difference of x's, so 6 minus 4 squared, and then the difference of your y's, which is 4 minus 0 squared, and then we'll just, square root all that and see if it comes out the same. 6 minus 4, that'd be 2, and 4 squared, so that'd be 4 plus 16, I guess, or square root of 20. And actually, I'm not even going to break it down in simplest radical form because I'm just trying to prove that they're congruent. So if I can show that the other side, Kn, has the square root of 20, or is the square root of 20, I guess I should say, then you are proving that those sides are congruent. So here you would go, I guess, 4 minus 2, and then squared, and then the second part would be plus, and then 2 minus negative 2, which should be plus 2 squared. So notice you're still going to get 2 squared, and then plus 4 squared, which is going to get you 20. So that's verifying that those two sides are congruent. So you can use a combination of two sides congruent and the same two sides parallel, which were the first set right there. You could also go and find the distance between your two other sides, LK and M, to prove that the sides are congruent as well. So all of those different combinations would prove that this thing is a parallelogram. So many different ways. There's not one single way. That's kind of recapping on all that. Find the value of x. The quadrilateral is a parallelogram. So check this out. I guess if you have two sides that are congruent here, and then you got two sets of angles right there. If we know that those two angles are supplementary, then we can say that the two lines are parallel. Therefore, it's a parallelogram, because the sides would be congruent and parallel at the same time. So we'll just set these not equal to each other, but we'll set them equal when you do the sum of them to 180, since they should be supplementary there. All right, and I think that'll be like something like 24x. Once you combine like terms, that should be plus 12, and then equals 180. And then we'll subtract 12 from both sides, and then divide. So I'll use my calculator for that. 24. So 168 is 24x, but then when you divide, x equals 7. So that would be the value of x that would make those two angles supplementary. If those two angles are supplementary, then those are parallel lines. Therefore, those sides are parallel and congruent. So I kind of like these problems right here. These are ones where you have to go find some of your missing angles. There's a bunch of different angles going on here. We're going to use the fact that we have some parallel sides. Don't forget your opposite angles are congruent. Also, you have these diagonals here. So actually, if you think about this here, you're going to have alternate interior angles. For example, if this angle down here by 35, if you have that as 35 degrees, by alternate interior angles, B should be the same exact angle. So I'm going to go ahead and put 35 up here. Okay, by alternate interior angles, this angle down here, 20 degrees, should be the same thing as angle D. So I can go put 20 degrees right there. All right, and I think we have another set. Oh yeah, we got 40 degrees by alternate interior angles again. So we got all that going on. Okay, but then after that, we can't use any more alternate interior angles. We don't know what A is. We don't know what E is. We know that they're congruent, whatever they are, but we don't know what they are. So there's a couple different things you can do here. You can say that these angles here, the big angles overall, I guess I should say, like that angle S with the angle P right there should be supplementary. So you could say all that adds up to 180. What I typically do here is I see a little triangle here, so I know all the angles in a triangle add up to 180. So that's actually what I'm going to do there. So I'm going to say 20 plus 40 and then plus angle F and then equals 180 because it's in a triangle, right? So that's 60 altogether. 60 plus F equals 180. And then subtract, and that's F equals 120. Right there. Obviously not drawing the scale. But that's 120 degrees. Therefore, you got vertical angles. This angle right here is 120 degrees. Okay. Check this out. You got a linear pair of angles right there. So if you have a linear pair of angles, this angle should be 60 degrees right next to it. Straight lines should add up to 180. And then now I'm going to go off to the side here. Now I'm going to say all of these angles inside of this triangle should add up to 180. So we'll go 60 and then plus 35. And then equals 180 again. Okay, and I think that's was that 95. So then when you subtract, I think A is going to be 85. All right, so angle A, 85, therefore angle E, 85. And then we are done. We hit every single angle. And then that's when I go off to the side and start listing out all the angles. I actually find all the angles inside the figure first, and then you can just go write them all in easily. I don't try to find it in a certain order or anything. If you follow like the right hand side, sometimes you'll feel like you need to go in a certain order. Like we didn't know what A was until the very end, so that's why I like to fill it in on the left hand side first. We got 85 there, and then F, oh yeah, 120. And then there you go. Okay, next few here, determine the values of the variables for which the figure is a parallelogram. So notice here that it looks like we got our two sides right there being 4x plus 20 and then x plus 26. So if this is a parallelogram, those sides should be congruent. So let's find a value that makes those sides congruent, aka set them equal to each other. So when you subtract over x, you're going to get 3x. If you subtract over 20, you're going to get 6. And then x equals 2. Okay. Now, if you try to set these sides equal to each other, notice that they have different variables. So if you initially did that, you're not going to be able to do a whole lot. So what I'm going to do now is I'm going to say 7y equals 6x. But instead of x, we know what x is. We just got x was equal to 2. So I'm going to plug in 2 right there. Whoops. 6 times 2 plus 9. And now we can solve for y. So what is that? 12 plus 9. So I think that's 21, which means y is 3. And those would be values for x and y that make your two opposite sides parallel. Or I'm not congruent, actually. Okay. Look at this one right here. Notice this one you have these two right here, and if you set those equal to each other, x equals 2y. You can't really do a whole lot with that right now. But check out your other two diagonals, or split up diagonals right here. Remember, the diagonals should bisect each other. So therefore, these should be the same if it is a parallelogram. Alright, so we'll subtract over 2x, that'll get us 3x. We'll add 4 to both sides, that'll get us 18. And then therefore x is equal to 6. And then now that we have x equals 6, I'm going to say 6 now equals 2y, therefore y equals 3. And those would be values for which your bisectors are congruent. So not too bad on these. Most of these are intuitive. The only thing I can see you guys messing up on number 9 is accidentally setting the two angles that are side by side maybe equal to each other, which we got to remember the side-by-side angles are those consecutive interior angles. We need to know that those are supplementary. So I'm going to go here, I'm going to write 12y plus 8 and then plus 5y plus 2 equals 180. They are not congruent, they should be supplementary. Alright, so this will be 17y. This will be plus 10 and then equals 180. And then I guess we'll subtract 10 from both sides. 17y, and then equals 170. And then if we just divide that by 10, or I'm sorry, if we divide that by 17, you get y equals 10. Okay. Then after that, then we can go and say it's two different things you can say. You can say that the two opposite angles are congruent, or you can say the two consecutive interior angles are supplementary. In my opinion, I think it might be a hair easier to use the opposite angles. So I'm going to say 2x equals 12 and then times y, which was 10, and then plus 8. So I'm just setting those two equal to each other and plugging in at 10 at the same time. So that's 2x, that's 128 once you get that. So then x, I think it's going to be 64. So a little bit larger of a number there. That should make those two angles congruent. Alright, now these are slightly different here because it says find the value of x and then tell whether the figure must be a parallelogram or not. So actually when I first did these problems here, I kind of misread them a little bit and I just said, oh okay, just set two pairs of sides equal to each other. So I went and said we got 3x minus 2 and then equals 2x plus 6. And then and we know that because they didn't tell us it was a parallelogram, but they told us that the sides were congruent. So I can just automatically assume that. And then when you subtract over your 2x, you're going to get x on the left-hand side. If you add 2 to the other side, you're going to get 8. And then what got me is I just said, oh, okay, then x is equal to 8, and then you're done. But actually, look here, you're going to take this 8, and we need to verify that the other two sides will work out if x is equal to 8. So if we go 2 times 8 and then minus 4, we need to just double check and make sure that that is also equal to 8 plus 4. So right here you got like 16 minus 4, which will get you 12. Over here on the right hand side you do get 12 as well. So that does check off there. But it might not work every single time there, and that's why I need to go check the rest of the stuff going on. So let's see, I guess with this one here, we know that opposite angles should be congruent. So I'm going to go ahead and say, and let's see, did they mark anything? They didn't mark anything about this here. But then we'll just go and verify that all the angles do work out here. So we'll say x plus 30 equals 2x. Therefore, if you subtract over x, it's just x is equal to 30. Okay. And then what I'm going to do here is I'm going to go plug in 30 back into each one of the angles and then see if everything works out. So if I got to plug in 30 right here, 30 plus 30, that's going to get you 60 degrees. If I go plug in 30 back up here to this angle, that'll be 2 times 30, should be 60, and then plus 25. So notice that right away. That'll get you 85 degrees. And we know that inside of a parallelogram, consecutive interior angles need to be supplementary. Right? Therefore, I don't think x can actually be 30 and this thing be a parallelogram. So you just say, you can find one of the x's, but it's not a parallelogram. Here, let me just write it out. It's going to be really lazy there and use the parallel sign, but just write it out. It's a lot of letters there if you're not a good speller, but alright, anyways, there you go. This next one here, they tell us the two sides are congruent. So I guess we need to prove that the two sides will be parallel, and I guess we can probably do this here with some alternate interior angles. So therefore, those should be equal to each other. Notice here also that you have all this junk right here. You actually have a full triangle right there. So what I'm going to do first, there's kind of multiple ways you can do this, but I'm going to go and just make sure I'm going to add these sides all up, and then plus 2x. I'll put the equals 180 on this side. I'm going to check what x is, and then I'm going to plug it back in and see if we got alternate interior angles congruent. So if you got alternate interior angles congruent, then you have parallel sides. You got 4x, x, and 2x. I believe that's going to be 7x. And then you combine your like terms, so it's going to be plus 5. Alright, so when you subtract over, you're going to get 175 on that side, and then equals, 3x. Or not 3x, 7x. And then let me just double check. 175 divided by 7, 25 apparently. Alright, and then I want to just verify real quick. If I plug in 25 back into x right here, that should get you 50 degrees, and 50 is congruent to the 50 up there. Therefore, your sides are parallel. Therefore, this thing is a parallelogram. Running out of room. Yeah, so it's a parallelogram. So the only one that was not a parallelogram was number 11. There you go. So that's just going back and double checking all the values to make sure everything works out. Now this one here, this is a good one here. This actually taps into substitution and elimination. Like most of you guys are going to do, you're going to set your opposite sides equal to each other. But the issue is we have multiple variables. But here's the good news. We have two different equations that we can use. We can use 2x and then plus 3y and then equals 19 as your other equation. So actually right here you have a system of equations. So that's two equations, two variables. If you have two equations, two variables, you should be able to figure out where these cross or where they have a common point right there. So there's a couple different ways you can do this. If you need a refresher on substitution or elimination, you can go into Google or YouTube or something like that, type in substitution and elimination problems. There's about 100 million different videos that you can find on that. So I'm just going to give you a quick recap. What I'm going to do in this one is use elimination. I notice if I add my two equations right away, negative 3y plus 3y, those would cancel each other out. And you're going to add up, you're going to get 6x and 2x, so that'll get you 8x. So we'll say 8x equals, and then we'll add the right-hand sides together. That'll get us, I think, 40. And then divide both sides, and that gives us an x equals 5. Now that we have x equals 5, you take that and you plug it back into either one of the equations, whatever you think looks easiest. And I'm always a big fan of the smallest looking number, so I'm going to use the one that's 2x plus 3y. So I'll say 2 times 5 and then 3y equals 19. Okay, so that's 10 plus 3y equals 19. Subtract over, that's 3y equals 9, and then y equals 3. And I believe that is it for our lesson today.